Hey there everyone and welcome to STEAMspirations. Buckle up because today we're embarking on a thrilling journey deep into the labyrinth of programming. Our destination? The mysterious realm of recursion. Ever heard of it? If not, you're in for a treat. If yes, stick around because we'll uncover layers you probably didn't know existed. You see, recursion is the elegant dance of functions calling themselves in a repeating loop, all to nail down complex problems. The catch? Each step to dance or solve is a near mirror image of the other. It's like peeking into a mirror and seeing endless images of yourself. Trippy, right? That's recursion for you. It's a way of making the mirror or function reflect itself. And in the world of code, it's a showstopper. Okay, let's break it down a bit more. You're faced with a monstrous task. Feels impossible, right? But what if you chopped it into bite-sized pieces? You tackle the mini tasks one after the other and bam, before you know it, the monster's tamed. That, dear friends, is the art of recursion. Now here's a crucial twist. Imagine you're in a never-ending maze. Sounds like a nightmare, doesn't it? That's why in recursion, there's this thing called a base case, our savior, the exit point of our maze. Without it, well, you'd be lost forever, and in programming terms, that's a terrifying stack overflow. After defining the base case, we then define a recursive step. This is where the function starts working in a loop by breaking the problem down into simpler steps. It's like saying, if you can't solve it directly, try solving a slightly smaller version of the same problem. A classic example of recursion is calculating factorials. The factorial of a non-negative integer n is the product of all positive integers less than or equal to n. The factorial of a number is expressed as n. For example, 5 factorial can be calculated as 5 factorial is the same as 5 times 4 times 3 times 2 times 1, which is equal to 120. So in other words, if we want to find the factorial of 10, we have to multiply all the numbers from 1 to 10 with each other. With that in mind, let's create a recursive function that can calculate factorials of numbers. In this Python function, we first define the base case. We can't calculate factorials of negative numbers, so the smallest number whose factorial we can calculate is 0, and the factorial of 0 is 1. So this is our base case. As soon as a recursive function reaches 0, the function will give a value of 1 to be multiplied in the recursive formula. For any other positive integer n, the function will call itself with n-1 as an argument. Now let's check whether this function works. Results equal to factorial of 5. This line calls the recursive function and calculates a factorial of 5. Print results. This line will output the results of what is a factorial of 5. In this example, factorial 5 will call the function recursively until it reaches a base case of n is equal to 0, at which point it will return 1. Then it will unwind the recursive calls, multiplying the values along the way, ultimately giving us a factorial of 5, which is 120. And if all that felt a little woo-woo, picture Russian dolls. Open one, and there's a smaller one inside. And inside that one, yet another. But at some point, you hit the tiniest doll, and that's our base case. So there it is, the magical, mystical, magnificent world of recursion. It's not just a coding technique, it's a philosophy, a way of life, a strategy to tackle the most daunting challenges. Always remember, it's all about breaking it down and knowing when to stop. If this roller coaster through the depths of programming got you all pumped, smash that like button and don't forget to hit subscribe.